Have you ever wondered how your phone just gets you? How it suddenly understands your accent, or how some new app can identify a bird from just one photo? Well, it's not magic, and I'll tell you this, it's not starting from scratch every time. It's all thanks to a really clever shortcut called transfer learning, and it's the secret sauce behind why AI is moving so incredibly fast. So, let's break down how it all works.
Just imagine trying to teach a computer to diagnose skin cancer the old way. You need a truly massive data set. We're talking millions of medical images, covering every single possible condition. And then you'd have to fire up supercomputers and let them run for weeks, maybe even months, just to teach the AI the absolute basics, like what a human cell even looks like. It is unbelievably expensive and slow, a huge roadblock for any kind of real innovation. So you see the fundamental problem here, right? If every single time we have a new task, we have to start from square one, progress is just going to crawl. There has to be a smarter way, a shortcut to intelligence. We can't keep teaching every AI the equivalent of, okay, this is a line, now this is a circle, over and over and over again.
Okay, let's think about how we learn. I bet when you first learned to ride a bike, you figured out the essentials. Balance, steering, how to pedal. Now, if you decide you want to learn to ride a motorcycle, you don't just forget all of that, do you? No way. You already understand the core idea of balancing on two wheels. You just have to adapt that skill. You are literally transferring your knowledge.
And right there, that's it. That is the big aha moment behind transfer learning. It's this simple but really powerful idea of letting AI do what we humans do so naturally. Take what it already knows about one thing and just apply it to something new and related. So let's be super clear here. Transfer learning isn't some specific algorithm or a single piece of code. It's more of a philosophy, a really smart strategy. You take a model that's already a general expert, say it's analyzed millions of photos and understands things like shapes and textures, and you give it a new, much more specialized job, letting it build on all that knowledge it already has. But what does this actually look like in practice? How do you really transfer the brain of one AI to another? Well, it turns out to be a surprisingly straightforward process. It really just boils down to three main steps. First, you start with your master model, one that's already been trained on something gigantic, like all the images on the internet. It's your seasoned pro. Second, you adapt it for its new specific job. And third, and this is the key, you fine-tune it. You just give it a small, specialized set of examples to practice with, which sharpens its general knowledge for a very specific purpose. It gives the new model an absolutely incredible head start. And while this feels like some cutting-edge, brand-new idea, its roots go back surprisingly far. The core concept was actually being explored in academic papers as early as 1976. It just took decades of refinement and, of course, a whole lot more computing power for it to become the powerhouse technique we see today. Okay, so that's all the theory. But where does transfer learning actually show up in our lives? You might be surprised to find out you're probably interacting with it every single day. Let's kick things off with language. Natural language processing, or NLP, is all about teaching computers to understand the tricky stuff in human speech. The nuances, the sarcasm, the context. It's incredibly complex. And for a long, long time, progress was painfully slow. But then transfer learning came along and completely changed the game. Big models like Google's T5 are pre-trained on just a colossal amount of text from the internet. They're not just memorizing words, they're learning the relationships between them. They learn things like king is to queen as man is to woman. This deep grasp of language structure becomes this incredibly powerful foundation that you can then transfer to almost any text-based task you can think of. And once you have that foundation, you can build specialized tools at lightning speed. Want to know if the thousands of reviews for your new product are positive or negative? Easy. You fine-tune a model for sentiment analysis. Need to sort a million news articles by topic? That's just document categorization. Have to get through a 50-page report before lunch? A fine-tuned model can spit out a summary in seconds. And that whole fine-tuning process is exactly what this visual shows. You take that powerful, general language expert, you feed it a small, focused data set, say a few thousand product reviews that are labeled positive or negative, and it quickly becomes a highly accurate specialist for that one single job. Okay, but what about sound? Well, it turns out the exact same principle is revolutionizing how machines listen to and understand the world around us. Think about speech recognition. A model that has already learned to understand English has already grasped the fundamental frequencies and patterns of a human voice. That gives it a huge leg up when you then want to teach it German. You're not starting from zero. The same idea applies to everyday sounds. Once a model learns to tell different audio patterns apart, it can be fine-tuned to identify pretty much anything from a dog's bark to a smoke alarm. And that brings us, finally, to sight. Computer vision, the quest to give machines eyes, is maybe where transfer learning has had its most dramatic impact of all.
So, a model that's pre-trained on a massive image library like ImageNet has already learned the visual alphabet of our world, things like edges, textures, colors, basic shapes. We can then transfer this fundamental visual knowledge to some incredibly specialized tasks. That same basic understanding of shapes can be fine-tuned to spot a stop sign for a self-driving car, or just as easily to highlight a potential tumor on a medical X-ray.
So, when you pull back from all these different examples, what's the big takeaway here? What's the core idea that really makes transfer learning so incredibly powerful?
It really all comes down to this. By standing on the shoulders of giants, so to speak, we can build highly accurate, really powerful AI without needing a Google-sized budget or a Google-sized dataset. It makes cutting-edge AI accessible to so many more people for so many more problems. It is the ultimate blend of efficiency and power.
In the end, the philosophy of transfer learning is actually something we've all known for a long time. Don't reinvent the wheel. Use what has already been built to create something new, something better, and do it faster. And that leaves us with a pretty fascinating final thought. We've just seen how this principle is accelerating the pace of artificial intelligence. But if machines are proving that building on prior knowledge is the fastest way to learn, what does that tell us about the future of learning for everyone and everything else?